Now, based on the different kinds of functions that we have, right? Based on the functions that we have, there are some values which are actually derived. As of now, we need not know. Whatever is needed for physics alone, I'll tell. Okay. So here I'll write it like this: function, which is f of x, or I'll call it as y also. Y or f of x being the same. And here the output of differentiation is called as derivative. Okay. Suppose I have a function like this, x power n. The derivative of this function is given as n into x power n minus 1. Okay. I told you, don't ask me the reason. Now I can't tell also. You need to know binomial theorem and all those things for you to derive. As of now, don't worry also. It's not a part of your headache. So x power n is nx power n minus 1. Suppose I have a constant. Derivative of a constant is always 0. But derivative of constant multiplied with x power n is not 0. Meaning, see, for example, if I have a constant multiplied with x power n, so d by dx of c into x power n, you cannot write it as 0. What you actually do is, whenever it's a multiplication factor, you take the c outside, you take the constant outside, and you'll write it as d by dx of x power n. So answer will be c into, use this expression, n into x power n minus 1. It's a multiplication factor, coefficient. So it's constant multiplied with. Okay. As of now, I'll use an into mark, but going forward, I'll not use it. Into, basically, we use it only for cross products. Right. So here, whenever you have a bracket, into a bracket, it is like one value multiplied with the other. So the answer here is going to be constant multiplied with nx power n minus 1. Am I clear with this? Right? Then derivative of sin x is cos x. And derivative of cos x is minus sin x. Am I clear with this? Right. As of now, make a note of these values. Right. Till this step, is it clear? Now, see, sometimes what happens is, like how a constant is getting multiplied with a function. X power n is a function. Accepted? Right. X is a variable. That variable is raised to the power n. It's some function. So it is not always necessary you will either have only x power n or only constant, or constant multiplied with x power n. Sometimes there can be the algebraic operation that is taking place between two functions. For example, that we call it as algebra of functions. Okay. Suppose I have a function f of x plus g of x, and I am interested to find the derivative of it. Right? If I'm interested to find the derivative of it, then let me call this f of x plus g of x as some y. Then dy by dx in this scenario is given as d by dx of f of x plus d by dx of g of x. Now listen. When I have y is equal to f of x, right? Listen to this carefully. Then I can write dy by dx as d by dx of f of x. This is one way of writing. Or I can write this as f dash of x. This is another way of writing. Or I can write this as y dash. Or I can write this as y with a dot on top of it. Everything means differentiation. Everything means differentiation, and this is called as the first derivative. Means you're differentiating the function once. You can ask me a question, can I differentiate the function second time also? You can. It's called second order derivative. If you do it three times, you call it as third order derivative. Okay, just to extend this concept, if at all you differentiate the function twice, then you will have something like this: d square y by dx square, which is also written as d by dx of f of x, or this can also be written as f double dash of x. 2 dash on top of f represents you differentiate it twice, or it can also be written as y double dash, or it can also be written as y with 2 dots on top of it. Similarly, 3. It keeps going like this. We generally don't use this. If it is d cube by dx cube, then you'll write as f triple dash of x, y triple dash, y with 3 dots on top of it. Okay, this is just a notation. Just a notation. Okay. So having said this, what I'll do is going forward, I'll be using the dash notation. So I will write this as f dash of x plus g dash of x. I hope you are able to understand this. Now, it is not necessary that you always add the functions. You can subtract them also. Okay. But before that, let me take an example. For example, if I have y is equal to x square plus sin x. You know the derivative of x square? You know the derivative of sin x. So, dy by dx is y dash is equal to, what is the derivative of x square? How did we get the 2x? Because for x power n, it is n into x power n minus 1. N is how much? 2. X power n minus 1. 2 minus 1 is 1. So basically, you put that number here and decrease the power by 1. For example, I'll tell you a shorter way. Suppose it is x power 4. Put the number there, write x and decrease the power by 1. So 4x cubed. It is going to be 2x plus. What is the derivative of sin x? So that's it. This is all you need to do. Am I clear with this? Similarly, y is equal to f of x plus g of x is there. No. You can also have, this is the first one. You can also have y is equal to f of x minus g of x. Right. Then what will y dash be equal to? F dash of x minus g dash of x. Means if I take the same functions with a negative sign, so y is equal to, if I have x square minus sin x, then what is y dash going to be? That's it. Simple, no? Right? These two aren't they simple? Right? So make a note of this. The next algebra of functions is, and the derivative here, I can have the product of two functions, f of x into g of x. If I call this as y, then y dash is written as, see, generally you write it like this. Listen to this. This is first function, second function. Okay, this is what we do in our mind. There are multiple ways in which it is given in books. Some books will give you as u into v. Okay. So basically what happens is, first function into derivative of second function plus second function into derivative of first function. You follow a pattern. So what you do is, basically it is u into v dash, u into derivative of v plus v into derivative of u. So instead of u and v, I used f of x and g of x. Am I clear with this? Right? Okay. So if I take an example, for example, y is equal to, if I take x square sin x, I'm using the same combination of functions, x square sin x. So this is first, this is second, or if you have learned it as u and v, you can take this also, right? So y dash will be first function into derivative of second function. What is the derivative of sin x? cos x plus second function into derivative of first function. Done. This answer. Okay. And this kind of a rule is called as, you call it as product rule. So when will you apply product rule? When you have product of two functions. When one function is multiplied with another, we use the concept of product rule. Right? And let me explain the last one, then you can make a note of it. And the last operation that you have is y is equal to f of x divided by g of x. You call it as quotient rule. Then what will y dash be? G of x into derivative of numerator. So basically, denominator into derivative of numerator, you have to follow an order. Minus numerator into derivative of denominator, the whole divided by g of x, the whole square. Okay. So whenever you're doing this y is equal to f of x by g of x, right, you need to mention a condition saying that g of x is not equal to 0. It's something like rational numbers only. This is called as a rational function. It's called as rational function. Basically, it will be a rational function. Sorry, my mistake. So you can call this as a rational function if the numerator and denominator are polynomial functions. The numerator and denominator both are polynomial functions, then you call it as a rational function. Whereas what is rational number? Integer by integer, where both the integers are co-primes. Denominator should not be equal to 0. Similarly, here the denominator function should not generate a 0. Okay. For that, you need to know the concept of domain, which you learn in relations and functions in your mathematics. As of now, you have this in your mind. So if I take an example, y is equal to x square divided by sin x. Okay. What is y dash? Y dash is sin x into derivative of x square, which is going to be 2x minus x square into derivative of sin x, which is going to be cos x, the whole divided by sin x, the whole square. Sin x, the whole square is sin square x, not sin x square. You should not square the angle, you should square the function. Okay. So this will be 2x into sin x minus x square into cos x, the whole divided by, call it as sin square x, which is going to be y. Sorry, y dash. I hope it is clear. So what do you call this as? You call this as a quotient rule. So basically you have two rules. What are they? Product rule and the quotient, right? So you can make a note of this.